So, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by SEMGRIP. My name is Cody, and welcome back to Techstrong Learning. We've got an exciting presentation ahead. Before we get things rolling, I do have just a couple of housekeeping notes I'd like to review with you. First of all, today's session is being recorded. So if you'd like to rewatch our program or if you'd like to share this program with your team, you will be receiving an email with a link to access the recording right after we conclude our live session today. Now, if you'd like to engage with us, there are a couple of options to do so. The first option is the chat tab on the right side of your screen. So if you see that chat tab, let us know from where in the world you are joining us. It looks like we've already got people from all over the country and the world. So thank you so much for joining us in your respective time zone. We do have one poll that's live, and I'll be launching another poll here in just a moment. Just a little bit of preliminary information we wanted to see so we can help tailor this program to what everyone is expecting. So keep an eye out for that second poll as it launches. And if you have not filled out the first, go ahead and check that out in the polling section. Additionally, if you check out the handouts, you'll see there's a link to try SEMGRIP for free, so take advantage of that free offer. And before we close things out today, we are giving out 4 $25 Amazon gift cards, so be sure to stick around to see if you are one of our lucky winners today. So our topic is 10 security vulnerabilities every JavaScript developer should know. And I'm joined by Zach Zeleznik, Senior Software Engineer at SEMGRIP. So Zach, thank you so much for joining us today. I'm going to go ahead and launch that second poll, but while we wait on those results, how would you like to take it over from here?
I can just dive right in. Cool. So I'll give like a couple more seconds for people to kind of trickle in right now. But while we do that, I'll just say very briefly about who I am. So my name is Zach. I'm a senior engineer on SEMGRIP's growth team. And for those of you who aren't very aware of SEMGRIP, what we do is enable how software is built, helping developers ship more secure and reliable code at ludicrous speeds. Before SEMGRIP, I was looking at Snapchat in our hardware group, where I combined product analytics, software engineering, and statistical techniques to help drive customer insights for our spectacles, aka our sunglasses, and our drone products. For those of you just joining, we also have a poll out just to gain some familiarity with where people are kind of coming from, as well as their backgrounds and familiarity with security and associated programming languages. So for those of you who are a little bit less familiar with security, it's a big issue when it comes down to kind of cost, impact, and scope. So there was a recent report released by IBM that talked how much a data breach would cost a company. And across the nation, the average cost is about $4.5 million. And this cost keeps going up. And this, for healthcare and financial institutions, is a huge issue. In other news, recently we had some casinos get impacted by a cybersecurity incident. While they believe this was likely due to ransomware, this kind of shows again like how just security plays a role in our everyday lives, where if you were at the casino during those days, most machines were not operational, and the company itself was losing millions of dollars per day. So besides just security interesting us as developers and people who write software, it matters at state, national, international level. There's a lot of money that goes to securing systems, and it's something that all of us can do to make sure that we're protecting our software for our customers. So I don't know how many of you guys are familiar with OWASP, but what they do is they produce a kind of class of categorization of different security vulnerabilities, both on specific vulnerabilities, weakness enumerations, and categories. So today we'll be looking at a few of the different vulnerabilities represented by these categories they've identified in the top 10. And just for some more context as well, there's a bounty program produced by HackerOne that helps compensate developers who find security vulnerabilities, and they have their own categorization system as well. So we can kind of see here the top 10 bounties per vulnerability type, with number 1 rolling in at about $4 million for cross-site scripting attacks, as well as some other interesting ones that we'll cover today. So the first topic we're going to cover today are cross-site scripting attacks. And for those of you who are a little bit less familiar with a cross-site scripting attack, it can be as simple as just displaying an alert on a client browser's web page. So the big idea here is that malicious code can be executed and steal sensitive user data and send it to your attacker server at evil.com. An attacker might want to capture your log credentials for a bank and then run fake payments or steal data and send on the dark web. And the way this works is that JavaScript can suddenly be executed in places where developers least expect it. So it's important to understand how your site can be vulnerable against these types of vulnerabilities. So I have a little design challenge, and some of you who've done system design interviews might have seen this type of style of question before, but I think it's kind of relevant because you can kind of tie in like a common business ask into software requirements and then try to think from a security mindset how we might mitigate some of the security challenges. So for this hypothetical example, our PM or maybe our CEO has asked us to create a website where we can kind of post jobs. And each of these job listings will be submitted by community members and will have job title, company name, logo, and a link to actually apply to the job. And I listed some questions to help spur the thought process. And if people have ideas already of what security concerns they have, feel free to kind of post them in the chat, and we'll be going over a demo that demonstrates some of these vulnerabilities. So this was an example here where we didn't sanitize the URL. So if I go back for a second, there's a link out that will contain the job URL, and someone posted just raw JavaScript that was executed on this web page. So there's a cute little animation here that shows you've just been pwned with the cross-site scripting vulnerability. But this could be a more serious issue if, for example, there was sensitive data stored in like the application storage for this job board, like maybe your credentials for like the partner sites, or again, sending people to a malicious website where people think that this is the original website they're on. And React is going to stop enabling the JavaScript protocol from being executed in a future release. So this is something that some people are aware of, but it doesn't have great visibility, that not all URLs are actually web URLs. So some common attack vectors are misusing the URL search parameters, not checking for the protocol origin, rendering just arbitrary HTML content from untrusted user input, not checking the content type when you try to display an image, for example, using a library that's not very comprehensive with its standardization, or potentially trying to use regex expressions to parse HTML for standardization. So some mitigations you can pursue. One, obviously, is to sanitize and validate any input, whether that's URL search parameters or submitted user inputs, trying to limit the scope when possible, and always validating that the data is kind of what you expect to ensure you're not going to have any unintended mishaps. So another big category of vulnerabilities that we've seen more recently are server-side request forgery attacks. And there was an interesting one posted as a bounty and exploit on HackerOne, where an attacker was able to bypass expected checks. And the idea here is that normally in your development environment, you're expecting when you're running code on your server side, it's fully trusted, only you have composed the code and no bad things are going to be happening. But in some cases, there's a situation in which a user is able to submit code that's eventually run on the server. So in this exploit, a hacker was able to find out where all their Google Cloud metadata lived and how to essentially expose their private keys so they could take full control over the Shopify servers. So that was a critical severity issue, the Shopify patch, and it was a pretty good example of an SSRF attack. So just with that kind of example in mind, if you're building a web proxy, you might need to be aware of these type of challenges and figure out potential mitigations to ensure you're not going to be vulnerable to the same type of attack. So for just, again, a toy example and something maybe you can kind of explore on your own is if your client has asked you to build an application that communicate with external traffic beyond their firewall, and maybe this is you're working at a school and maybe you're a student and you typically have used a proxy before potentially to play like a computer game during class, and you might have used a proxy to get around the firewall. You could have potentially, if you were just deciding to build it yourself, put yourself vulnerable to some sort of SSRF attack if you're not specifically checking to see which resources are being requested. So I built a little demo where I exposed an API called proxy on localhost, and at the same time I ran a netcat server on a different port. So here on the bottom terminal, this is my sample netcat response. On the top left is my server, which is intended to just serve requests from localhost 3000, but I enabled someone to specify a different host. And this would mimic somewhere you're trying to play cool math games and you need a proxy that request. And instead of only exposing cool math games, you're actually exposing your local traffic as well. So in this example, you might want to have a mitigation to prevent external traffic from visiting internal ports. And this kind of goes to show you kind of where the attack vector could be coming from. In the case of Shopify, it was exposing cloud service metadata. But in my toy example, we had a situation where we're able to access internal ports because there was no standardization or validation of which hosts were viable targets. So some mitigations you can pursue is partitioning your services across separate networks to reduce the impact. So if Netcat was actually my SSH port, and I wanted to ensure that no one could actually SSH or run that service, I'd make sure they're on separate networks. Another option is ensuring you don't actually send responses to clients and disable all HTTP redirection by locking down local traffic and enforcing stricter security policies for that exposed endpoint. A third class of attacks I want to go into are timing attacks. And in this case, I'm going to give you a software design challenge where you have to add password protection. So for our toy example here, your client is Phony Pictures, and they've asked you to build a password protection for their companion websites for all new movies. And you can imagine like you have a summer blockbuster and you only want to send out the website to registered screeners. You want to have a simple password where you can share the password without needing to log in. And kind of the question is, as a designer, is how you will generate and store the passwords, and how do you verify passwords are correct, as well as how do you mitigate potential security concerns. So in this case, I'm going to actually pause and hope that someone has a few thoughts or concerns for how they build this. Okay. So one challenge in building these type of applications is securing the password and verifying the password. So assuming you're following best practices when it comes to cryptographically hashing and salting your passwords, it's still possible that you're vulnerable to a timing attack, where the idea is based on the operations you use to secure your system, you can leak some implementation details in the response times. So in the diagram here, there's someone trying to type in their password, and the server, in this case, an SSH server, responds with different latencies. So it's possible through brute force, a lot of measured timing response tests, they can kind of identify the type or class of possible passwords and their password lengths, and then brute force to gain access to the system. So some mitigations you can pursue are preventing brute forcing. So Apple does a pretty good job of this when you try to unlock your iPhone or your Apple Watch with the wrong password multiple times by adding delays between each attempt. You can also limit the amount of information gained from an incorrect attempt by adding artificial delays for both, the quick cases and the slower cases when you actually have to validate more checks. And there's some libraries like Argon2 or bcrypt that include some parameters to strengthen your defenses so you can ensure you're not leaking any implementation details in your response times. So the fourth type of vulnerability I want to go into is prototype pollution. And this is something peculiar or special with JavaScript, to the way objects are built. I believe we shared a poll about which programming language you're most familiar with. And I was hoping to get a little bit more guidance of where people's most familiar language are coming from. But just speaking more broadly here, JavaScript objects and properties can be tampered with. And this is in part because of the way objects are created and defined using the prototype constructor. So an attacker might try to find a way to inject code into the base object constructor and add properties or pollute methods that you thought would be correct. So in this little code snippet here, we're using the library Lodash, and an attacker constructed a payload that has the property isAdmin set to true. And once this vulnerable function is called from the Lodash library, any object will have isAdmin field set to true. And if you have some access control check to whether or not you can read customer data or modify customer data, this could be a path to having your database or sensitive operations gain unauthorized access. So some advised mitigations are using the set or map constructor, using freeze and seal mechanisms to ensure your data's classes are not modifiable, and ensuring your dependencies are up to date. Lodash is a very popular library. It has over 50 million weekly downloads, and that number has grown tremendously in the last couple of years. But they've had like over 7 different types of this vulnerability of just this class. So that's a case where you would need to be very sure that you're using the most up-to-date dependencies and you're not at risk to some of these vulnerabilities. So the fifth type of vulnerability I'm going to bring over is called mass assignment. So mass assignment is a situation in which you, as an implementer, are using a library or a pattern that makes it very easy to map your data model to the actual object creation. And the big idea here is that validating forms aren't very fun. And in some cases, the implementation is a little bit leaky, where an attacker might just pass in, they are the admin, along with their login or other user sign-up parameters. And the system might blindly just accept those parameters without validating them. So this was a situation that actually GitHub had. And the mitigation they did is basically restricting assignment to a set of known public fields that are non-sensitive. So an example would be the admin property, ensuring any sensitive fields are overwritten with your own implementation as opposed to being supplied by the user themselves. And another mitigation is using a library to support this safe listing or block listing feature. So moving on to our sixth category of vulnerabilities, we'll talk about NoSQL injections. So the tagline here is, it's not SQL, but it's still vulnerable to the same style of injection attacks that were popular with SQL back in the day. So for those of you who might like NoSQL, because in many ways it's easier to get set up with, it's still very helpful to be aware of the type of injections you might face. And an attacker, just like the traditional SQL, might be trying to essentially execute a query to retrieve all the usernames of a database as opposed to just what they're supposed to access, which might be their own username. So the way it works is that a user can potentially craft a payload that uses built-in verbs or expressions to deviate from the desired behavior. So in this example, the attacker is posting to the user's API endpoint with an object instead of a string. So instead of passing in, their username, they're passing in an expression where the username is not equal to null, which is then evaluated in the query engine and return all the users as a response. So some mitigations would include limiting and validating the user supplied data, which again is a kind of a common mitigation strategy. Trying to use what would be like a prepared statement in SQL with your chosen NoSQL provider, and disabling server-side JavaScript execution for providers like Mongo when possible. For a seventh type of security vulnerability, we'll be talking about RDoS, or regular expression denial service. The big idea here is that most regex engines can be very slow with particular inputs, and an attacker would be trying to create a service outage. So if you're a power plant company or a network provider or a CDN, an attacker could potentially create a lot of drama or costs associated with creating a denial of service attack. They might be testing particular inputs, measuring the response time. And because the regex engines has a lot of functionality, and some features such as backtracking can have catastrophic runtimes, this can cause a CPU to spike, as shown in the example image, where as the string gets longer, the CPU goes from like 2% usage all the way up to full utilization. And you can also see that this response time increased as well because the server isn't able to respond in time. So in terms of mitigations, one way is using only validated regex patterns from reputable online sources. Ideally, you're not creating your own regex expressions if you can just find them off the shelf for cases like IP address, email validation, phone numbers. If you do end up wanting to write your own regular expressions, ensuring the pattern you create doesn't use backtracking, and just avoiding the common pattern pitfalls through some tools like regex 101, which will show you if you have a catastrophic backtracking possibility, or using the debugger to make sure you're going to be able to execute the regex as you intended it to. The eighth category is security misconfiguration, and this one is more of a general category than a specific vulnerability. So for those of you who might be familiar with, setting up your router, typically the default is just admin or Cisco. And this can present problems when there's assumptions made about the services provided and kind of where they are on the surface of the perimeter of your attack surface, because there's going to be some sort of potential situation where if one device is compromised, it can lead to a series of exploits that compromises more sensitive material. So the big idea here is that security, like most things in life, come with a trade-off. So the usability might decrease, but your security increases, where you ensure that you are only giving passwords out on a singular basis, that they're encrypted, they're not using default credentials, or an attacker might be able to get privileged access through social engineering or other side channel attacks. And one kind of way this works is that there are a lot of IoT devices that use the same default security settings, and when these are exposed to the public web, an attacker can scan and enumerate all these vulnerable types of devices and potentially get access to security camera feeds, health data, voice data, and more damaging things as well, depending on how they're set up. So typical mitigation steps are just changing your logins and passwords, ensuring you're rotating passwords. And this is, again, pretty general as well, just ensuring you're configuring privacy controls, setting up MFA, ensuring your firmware and software versions are up to date. Number 9 is cryptographic failures. So this, again, is another type of vulnerability class, but specifically we're going to be looking at one, which is called hard coding passwords. So the big idea here is that while people typically say in the meta, you shouldn't roll your own crypto, in some ways you are, because you need to select, the right algorithm and ensure you're using it appropriately. So the attacker will typically try and get access to sensitive information by skirting around the way you've set up your authentication, even if you are using a valid crypto algorithm. So in this example here, we're using the Jose library. We've set up an appropriate algorithm to encode, some secret here, and we'd be issuing JOTs to our end user for authentication. However, we set secret as secret, which would mean that we're not really creating an enforceable security policy, because an attacker would be able to easily guess that the secret is secrets. And then that whole notion of whether or not you can trust the JOTs, goes into the dishwasher. So some mitigations would be using the basic encryption schemes with the proper parameters, ensuring when you're using the appropriate hash as opposed to just like a fast hash, doing your research on the design and usage, and ensuring that you're not hard coding your credentials or using insufficiently random secrets in your services. So the last type of vulnerability we're going to go into, or a class of vulnerabilities, known as broken access controls. And the idea here is that there might be gaps in implementations of your secure perimeter, and the attacker is going to try to exploit the weaknesses. And this could be scanning your subdomains and open ports, or just fuzz testing any exposed API routes with different HTTP methods. And you can see here in this fun picture, there's supposed to be a gate, but there's a few gaps. And that's exactly kind of how the attacker might view your system, as mostly working, but still vulnerable. So for some mitigations, typically you want to ensure you're enforcing consistent authorization across your various routes and resources, whether that's setting up auth middleware for like your Express server or Next.js router, having a security policy for your cloud resources, ensuring you can set your endpoints and resources to be denied by default instead of just public by default, and conducting important audits for security when it comes to ensuring that there isn't a way for someone misconfigure something as public when it definitely need to be private, through having automated alerting and access and audit trails. And I think the idea here is, if you're a developer, it's not just your job to keep things secure. It's not just a security engineer's job to keep things secure, but it's something that the whole company ideally can kind of be made more aware of, because everyone's job to secure user data. So some key takeaways here. First, just stay informed. So by attending this talk, ideally you've taken away a few of the common security vulnerabilities, and you'll be more aware of spotting them in your code or someone else's code. Second idea here is just kind of being proactive. So you can be proactive when it comes to setting default policies for your systems and resources, ensuring that if you don't have a consistent way of dealing with sensitive data, there's policies in place that ideally will be using cryptographic secure implementations for sensitive data. Having the security mindset, and this can be thinking as the attacker or as a security professional of ways your system can break down. And it's not just like a one-time task, but it needs to be done continually. So that way you're ensuring that, as your system evolves, so does your security posture. And there will be a quick little plug. As you can see in the top here, in one of my demos, I exposed a route that is intended to cat a file from a known public path, but it accepted user input, and you could specify the path separator, which would actually go outside the public folder into a root directory. So that's kind of where a static tool like SemGrep comes in, where you can actually run security testing from VS Code or your command line. The big idea with a product like SemGrep is being able to improve your software security and reliability. And in most cases, you are the defender. And in some cases, if you're an attacker, it's actually, more easily enabled to, find a bug in a million line code base for a big company than it is to be securing all your code and endpoints as the big company. So the way that we try to help developers is by looking at all the possible types of vulnerabilities that are needed by our contributors as well as our security researchers to really find the most likely exploitable vulnerabilities and ensuring you can kind of fix it or have a path forward to improve your security posture. So that's it in terms of content. We now have time for any questions. And I'll leave it to Cody to start emceeing again.
Yep, absolutely, Zach. So I do want to ask everyone to go ahead and send in any questions you might have. In the meantime, I do have just a couple of here that have been sent in already. So Zach, what kinds of companies use SemGrip?
Yeah, so SemGrip is used by a few companies you may have heard of, such as Instacart, as well as Figma. We have usage by open source developers across a few different cool projects. A lot of people who write Go like using SemGrep or Kubernetes files because you have decent YAML support.
All right, so you did mention an additional language here. So I did want to take a look at what additional languages our audience does have experience with here. So with everyone, please check out our polls on the right side of your screen. Those are still open if you'd like to respond to them. So Zach, all of these responses on here that are up on the screen were different languages that our audience was familiar with. Do any of these surprise you, or any of these you expected?
I think I expected to see maybe JavaScript a little bit higher on the list, but I was almost anticipating one, like Perl, to sneak up on there, and yes, it did.
Oh yeah, seeing lots of variety here. So we've got a group with lots of experience everywhere. So we'll take a look at our second poll here, and it was just asking what the current security experience level is of everyone in our audience. And so it looks like we've got a nice bell curve with the exact half majority of people at the intermediate level.
Nice.
So since we have, it looks like over 70% of everyone is past that beginner stage, send in your questions. I know we've got lots of relevant information that we could bring up right here with Zach. So Zach, our next question is, what languages does SemGrep support? So as we've just looked at all of those, are there any that are not supported?
I will say that I didn't know how many rules we have written for Perl, but I know that Python, we have a lot of really helpful rules on, especially when it comes to like libraries like requests or Flask. Because again, if you're writing some sort of web service, you're going to want to ensure you're not letting in arbitrary user input to potentially access unauthorized resources.
Gotcha, totally makes sense. Looking at our next question here, how would someone use SemGrip to catch these 10 vulnerabilities that you've been reviewing with us?
Yeah. So in my example right here, this was an example where there's a custom rule written to ensure that user input wasn't being able to get passed to this path join operator. And that was one of my test cases for running a exploitable SSRF attack. So the way it would work is you just run semgrep scan in your repository. So in this case, I ran it into one of my demos, and it caught this issue. So if you set up, continuous integration with GitHub, we have a GitHub Actions workflow. Recently, I built one to make it even easier to get set up, where you can just run semgrep install CI. And there's a lot of different kind of ways you can set it up. But I guess idea here is it should be dead simple. It should be one command to run. And then if there are known security vulnerabilities, it'll show right there. We can also write your custom rules. If, for example, you have your own custom router or implementation where you do know of current security vulnerabilities to ensure people are always making sure they're writing secure code.
Perfect. So let's take a look at those 10 vulnerabilities that we've been reviewing. And if you had to pick one, maybe two, to flag as either the most critical or maybe the one that you see the most occurring, was there one or two that you could narrow it down to as one of those two categories?
Yeah, so I think the first one, like the cross-site scripting attacks and SSRF attacks, are the most important. That's why I put them in the front. Um, so I think, for example, that that's one of those issues you would never expect. Like this, again, was a HackerOne report where a Shopify infrastructure got compromised all the way to the top. This user was able to actually take control of the Kubernetes cluster, or able to create new resources in Kubernetes, could destroy all Shopify's infrastructure until they backed up again. Could have been listening in on all network traffic they wanted to, and all they really did here, as you can see, is like this 4-line script, or they created a script tag and it said, "Hey, let me fetch some metadata from Google," and because it's running on Shopify server, everything is possible. So that's like an issue that people don't typically expect, but can basically lead to critical vulnerabilities.
Very nice. Okay, that totally makes sense there. That seems like a big thing that we will need developers to address. Awesome. Our next question says, how does SymGrip determine whether a vulnerability is reachable, and does the tool show the user the full exploitable path?
That's a great question. So it depends on the type of vulnerability. There's different vulnerabilities when it comes to a first party or a third party type of vulnerability. So in one of my examples here, we talked a little bit about some, things specific to JavaScript, like prototype pollution. And you can see here that, if I am using Lodash and I use a merge method, and I'm using a version of Lodash that has this vulnerability enabled, we'll be able to test that based on like your package.json and log file, and then see whether or not any of these vulnerable methods are used. And then I'll let you know whether or not you're using a vulnerable library, as well as you use a vulnerable function, and whether that code is reachable. So typically we will show some reachability with a section of that path. In my example, just using the SymGrip static code analyzer with first-party code findings, you see the corresponding log line, but the full path may or not be exposed depending on who wrote the rule.
All right, Zach. Well, I am not seeing any more questions at this point in time. So if I want to ask you if there's anything that you feel our audience should absolutely walk away from this program having top of mind. If you have any tip or one piece of knowledge that everyone should walk away with, what do you think that would be?
I think probably I would direct this back to the takeaway slide here, and just say that we're all kind of responsible for our business or company at the end of the day, and ensuring that you feel that you can make meaningful contributions to your company's security is, I think, everyone's job. So it's in some cases like not ask like what the security team can do for you, but what you can do for the security team, right? Could be that kind of the final thing to walk away with.
Gotcha. That one should be easy to remember. So Zach, thank you so much for joining us here on Techstrong Learning. It's been such a good experience talking with you today and getting to know you before we went live today. So thank you so much for joining us and spending time with us.
Well, thank you, Cody, and the rest of the Techstrong community.
Of course. So to our audience, just a reminder that today's session was recorded. So following this program, you will receive an email with a link to access the recording on demand. You can also find this living on the Security Boulevard website. Just visit securityboulevard.com/webinars and look in the on-demand section where it will be patiently waiting for you. The 4 winners of our $25 Amazon gift card drawing are Mariana B., George D., Dario A., and Nathan F. So to our 4 winners, keep an eye out for an email from me. I'll be reaching out to get this gift card out to you. If you don't happen to see that email, check your spam folder just in case it happens to be filtered out. I'd like to thank SemGrip for sponsoring our program today. And to everyone who can still hear me, thank you so much for sticking around. We appreciate you joining us today, and we do want to hear your thoughts. So I've placed a link in the chat, but feel free to just stick around until we close out, and you'll be funneled into our survey. We'd love to hear your feedback, whether it's about our program today or upcoming topic suggestions. Just let us know there. Either way, we do hope to see everyone at a future Techstrong Learning Experience. Have a great rest of your day. And Mr. Zach Zalesnik, thank you so much for joining us.
Thank you.